Hey everybody. Just wanted to take a half a minute and acknowledge that my amazing wife, who recently passed away, is the one that helped me bridge the techie uh, gulf that I was scared of touching. And she helped me make so many of these videos in so many ways. She was a techie in our family, and she's the one responsible for getting me to do all these things. And this is the first video since she passed. So yeah, and I had started this on this work before anything had happened. So here it is. I'm going to talk about block detection, and I'm going to talk about the specific one, but this is applicable to many other situations, right? So any block detection that you might have, in this case, I'm using something called the DB20, and it has a magnet in the center and a hole in there. And what you're going to do is you're going to coil things in here, and there's tons of videos that I've put in the link that that show how to wire this up. It has 4 outputs, very nicely under the on the back end. It tells you which each one is. So negative is on the far left there, and I'm sorry, the other way around. Ground is on the far right over here. And we're going to show you how to wire all this up. And I'm going to do that pretty quickly because there's plenty of good videos to show you how to do that. And here is here's the particular brand, the NCE BD20. What I'm going to show you is the timing, because the timing that you get out of this, and what you can do is, of course, attach. You can use 2 outputs, and there's several videos on this. The middle 2 outputs can be used as pluses to trigger a gate coming down, some lights flashing because the train is going through. Maybe you want the water spout to come down. I don't know. You can put a bunch of relays in a motor and things will go. The problem is, or at least the one I ran into, is that you have to have an engine on a chunk of track that is insulated, and that engine is, because it goes through, it creates a short. Effectively, the current from one rail to the next travels, right? And that short then is what triggers this. So if you have a very long train of cars, of any kind of car, box car, tank cars, hoppers, whatever, it will only trigger while the engine is on that track, right? So what do? Well, you make a huge, long, insulated track so that while the engine's on there, it creates the short. Now, of course, if you have a lit caboose, that's another way of doing it, but that'll be only at the end, and only when it comes onto that insulated track will things stay on, right? So I didn't like that restriction. I didn't like the fact that the length of the track is going to dictate the timing that I can operate things, right? I wanted to have a flexibility of using this as the trigger, and then choosing how much time everything else was going to function. And that's what here is the board that we will be talking about, and I'll show you the details of. And what you see is there's an LED right here that will turn on, but here's the DB20, and when this engine, that's very loud, goes through the insulated track right here, very short insulated track, this will turn on. When it passes, it will turn off, but this circuit will continue for the amount of time that I choose, using this little screw on this potentiometer that's hard to see. All right, let's get the engine through. Here comes the engine. It hits the insulated track. This LED is on right here from the DB20, and it will stay on as long as that engine is on that track. As soon as it comes off, then the DB20 stops, but this circuit continues providing current through this ground, black ground, and this red positive that I could send to anything, to a gate, to a turntable. And I'm going to turn off the engine because it's so loud. And you can see it just continues. And I've set this for 51 seconds, and I won't keep it for 51 seconds. But you can see I did it on this very, very short, it's triggered on this very short amount of, from here to here, of insulation. I don't need a long piece of track to trigger. And this went off, actually I think I set it for, maybe this one was set for 23 seconds. So yeah, not complicated, pretty easy. And you can see the red positive went through the magnet of the DB20, and then it goes to my DCC in the alligator clip. Here's my positive, here's my negative from my DC power supply, very clean DC power supply. And there's the LED. So not hard. So before we get started, please learn from my mistakes. Do not repeat this, right? So when you're dealing with IC electronics, power supplies are not the same. You cannot, the same 10 volts from one place is not equal to the 10 volts from another place. You know, so if you're like me, you've got many of these little DC power supplies from boxes that you've bought and sets that you've received and all these other things. And I thought, great, you know, I turned the knob, made the measurement, got 10 volts out, and we'll talk about why 10 volts. But these things are noisy, the DC signal out of this, and I didn't know that. And of course, I don't know anything about electronics in general, which, by the way, given that I can do this, anyone else can. But I have a friend who's good with electronics, and he said, oh, you know, these are very dirty, right? So he pointed me to this very nice unit. It's very clean, very constant DC power, and it's controllable. I can choose the voltage. I can always see the current that's on here. Here's 10.7 volts. It has a nice red lead. Again, because I don't know anything about electronics, it's always hard to figure out which one is positive, and red is positive, black is ground or negative. And you know, you just hook them up, everything's color coded. It's quite nice. It's a little more expensive. That may be the challenge with this. You can go on to Amazon and you can find lots of very different ones. Here's an example of one that I was told is a very constant, nice DC, but it's set at 12 volts, so it's not adjustable. And everything I'm going to show you, you could use 12 volts, so no real problem. Yeah, but make sure you have a clean power supply. Don't do what I did and do this thing. That is just, I really thought I had completely screwed up, and I was tearing my hair out because I couldn't get anything to work. But the sensitive electronics that we're dealing with, they're just not going to function that way. All right, part one, the block detector, so the BD20. Not too complicated. There's lots of videos, and I have links below to show you people who talk about how to connect them. There's only 4 things you need to know. You're going to get it done in about 5 minutes, I swear. It's fast, right? So there's a magnet. There's a hole in the magnet. You're going to take your DCC wire that goes to one of the tracks, so you're going to wind it around here like this, right? Two winds is plenty for the O-scale trains I use. It does the trigger. It has to be a DCC signal for the BD20. You can use, as I mentioned, any other DC block detection will work through the electronics we'll talk through. There's a red LED right on the board, so when the short when the engine is going over your track, this will light up, and it's very clear that this is sending out a signal. The third thing to know is that sorry about that. There is 4 outputs. I'm sorry, there's inputs and outputs here. And you have a plus and a minus. So the red is going to come in here, the black is going to come out here. This can go to an LED if you want to, and this is the logic signal that we will be taking things out of, is this third little pockety things. You unscrew it, you put the wire in there, and you screw it down, tighten it down. Other people have taken the signal out of this one too. That's perfectly fine. No problem here at all. All right, the fourth thing, which you don't really need to in my situation, is that there's these little 3 holes for a potentiometer in case this is overly sensitive. Meaning you get too many false positive, meaning somehow it triggers even though the engine was not on the track. Could be you have too many loops, decrease the number of loops, or just put the potentiometer here and increase the resistance, and you'll be fine. All right, not too complicated. The BD20 is about 2 inches long by about 1 inch wide, so not a big piece of equipment. Completely handleable. Again, 5 minutes, right? Here's how to wire it up. Which is not always shown, right? So the first thing you need is an insulated piece of track. In my case, in this case I'm not showing particularly long, but it's insulated up here, it's insulated down here. Out of the right rail, you could be the left if you wanted to, but it goes through, it loops through right in here, and then comes back out and gets hooked up to the right rail, right? And then the left rail connects to the other part of your DCC system. Not complicated. 10 volts plus, red, goes here. Negative comes out of this signal, goes to ground. And then we're going to take the logic signal, and again, these are these little screws here that we talked about. And this is what's going to go to the rest of our electronics that I'll show you in a minute, right? So not complicated. Not complicated. And here's the NCE diagram, right? And they show you how to put in an LED so that just to see that it works. But you can keep the LED on to tell you, oh gee, the BD20 is working. But again, I mentioned there's an LED built into the board, or at least a version of BD20 I have. And as we talked about, this will only send out a logic signal while the engine or the caboose, or if you have passenger cars that are lit, are causing a short, right? So if this is short, then the signal is short. If this is really long, then the signal is really long, and you don't have a choice as to how long the things, the lights, the gates, the turntable are turning. And you can only control that by the length of this track. And that's what we're going to try to add to this really cool piece of electronics to give you the time control. And that's part 2, the timing module and how to connect it up. It's not hard. And this is a 555 chip. And, again, I don't know squat about electronics, but it has pins 1 through 8, and they're numbered this way. Not on the chip, but you just have to know. And because there's a little indentation at the very top. The left is 1, down to 4, and then up 5 through 8, going this way. And all you're going to do is you're going to wire it up this way. And I've got links below that show you much better than I could how to wire this up on a breadboard. And I use the breadboard because I suck at soldering, and I don't want to solder tiny little connections like this. It drives me nuts. The other thing I did is I added the reds, the color red on the wires, so that you know what's ground and what is positive, because for me that was kind of confusing. right? And then, so not too complicated. There's an LED here with a resistor of 470 ohms plus, and then it goes to ground. This is what's going to turn on for a certain amount of time. And the timing is going to be set by you based on this potentiometer, which we'll get to in a second. The other thing that's attached here is this capacitor, 470 microfarads. Microfarads, what a weird unit. Anyway, and then the other thing, because I'm not good at this, VCC means plus and it's red. Ground, it means negative and it's black, right? I always need all this extra jargon. And then you're going to have a potentiometer, and it has 3 leads, and we're only going to use 2 of them. We're going to use the one on the right side and the middle one, and we're going to change this, and it's going to change the resistance of this whole system. The time that this LED is turned on for is this simple equation. It's the 470 microfarad. So you could get a bigger capacitor, capacitor if you wanted to, times the resistance that's in this potentiometer. So as I make this move it up, there's more resistance, the timing goes up. The equation is not quite right. It's actually 1.1 times all of this. But even so, you know, these things are not always exact. So the way I time it is I push the button right here, and then I time this LED, how long this LED is. And I was able to time it to 51.38 seconds, right? So I just keep tweaking this a tiny little bit at a time until I got my 51.38 seconds that I wanted. So I don't rely on this equation. I just turn on the little timer in my iPhone. I push this button and off it goes. What we're going to do is we're eventually going to toss this little unit right here, this thing, and we're going to put the signal from the DB20 to trigger this whole thing to go forward. All right, here's what it looks like, and here's what you're going to need. Here's the 555 chip. The little notches up here, 1 through 4, 5 through 8. Here it's on a breadboard. You just press it in. They're made to go on a breadboard. Very nice. Here is the potentiometer. The pin you want is 1, and the center pin right here, 2. And this screw, and I chose a 500 kilo ohm resistor, so it gives me a lot of range for the timing. And I just keep turning this until I get the right timing. You're going to need wire, black and red. Please use black and red. It's going to visually help you for if there's any issues. I use 20 gauge wire because the 20 gauge wire goes very nicely into these little holes. 22 would have made it a little tighter, which might be better because I don't want to solder. So when this thing is turned upside down and glued to something, I don't want any of this to come out. And by the way, these little half mini boards are very nice, very inexpensive. They have little notches on the front, on the back, on the side, so you can attach them any way you want. And they have a sticky back, so you can put them anywhere you want. Here is the capacitor, which has a long lead and a short lead. The long lead is plus, the short lead is negative. I hate that because I always forget short versus long, but for capacitors they did a very nice thing, which they add a negative to on the actual unit itself, so I always know where negative is, right? And then here's an LED, same thing, a long leg and a short leg. Long is plus, short is minus. I think that's right. And if you reverse them, of course, the LED won't come on. So sometimes you might have, if the LED is not coming on, it's not that you've done anything. You may have to flip these 2 leads. Especially for me, at times, because I don't want such long legs, right? So I'll use clippers and I'll cut these, but then I forgot which one is positive and negative. Real pain in the butt. All right, the last thing I have is a nice little meter that can measure voltage, current, and resistance. And here it's assembled, and you can see I've moved things down, right, so that it's not all clustered right around this thing, right? So the resistor goes from the 3 input here to out here, and then here's where my LED is, and there's plus and minus um, strips, sides on both sides, right? That's why these are interconnected. Here's my power supply, red for plus, black for minus. Uh, and I put in these posts so that these clips go on very nicely. So, not hard. I put links on below as to people who show how to assemble all these, because you don't need to. You don't need to see something from me that's done perfectly fine. Here's the trick. Here's that wire right here. This is the logic signal plus that goes into number 2 of this unit that is going to trigger this whole thing to start. And just really, really nice. And I just love it, you know. And actually, I just realized this. This is actually being plugged into number 1. It's actually should have been plugged into number 2. That is just I assembled it this way to be able to take a picture and put it into the wrong slot there. So yeah, number 2 into this pin right here. And you know, I just turn, and by the way, I moved the pot way down here, right? The potentiometer is way down here. And I just take a wire, move it to pin 1 of the pot, take pin 2 of the pot, and move it into the plus side, and I turn this, that screw, until I get my 51.83 seconds on that LED, right? So not hard at all. The next part is how to connect the BD 20 to the board that we just talked about. And I'm just going to show you the diagram, and then we'll go to the pictures of what it looks like, and then we'll show it to you operating. What we did is we tossed this little button actuation, because we don't need that, nor do we want it, it's just extra. And the logic signal from the BD20, that 3rd screw, comes in here, directly in here. And then I adjust this, as I mentioned, until this stays on for 51.38 seconds. And then what we're going to do is we're going to take the signal out of pin 3, and we're going to start triggering our lights. We're going to start triggering our gates. We're going to trigger whatever you want for however much time you want this thing to be on, right? What's important is not to take the signal here, right? Don't take the signal here. Don't take the signal here. Take it before the resistor. Also, I lose 1 volt roughly in this, in the electronics of this, which is why I end up using 10 volts, is so that I have 9 volts coming out of here, right? And I take my signal, and that's going to go to the next bits and pieces.
Let's bring it all home. Here is all 3 components that are integrated together. So here's the the BD20. And as you saw how we all hooked it up, the DCC box to the right rail. Here's the logic signal that goes into pin 2 without the push switch anymore. That's been removed. Here we take the plus sign, the plus um, from the current out before the resistor, and it then goes to this. This is the NCE lighted detector, right? And I'm just giving you an example of how you could use it, right? So it gets hooked up your ground. Here's your plus from your um, uh, 55 chip. Remember, you might have positive 10 volts going in. What comes out is probably a little less than 9. And then you just wire it up the way that NCE tells you, and or there's videos on how to do rail crossings with all of these different kinds of lights, which is really cool. There's lots of effects you can do with this thing, right? So this is how it's all connected together. Now, this works as long as this, whatever you've attached it to, does not pull a lot of current. If it pulls a lot of current, your LED is going to go dim. You're not likely going to be powering this enough, right, to make this. So LEDs don't pull a lot of current. This is not very much of anything. So this will be just fine. If you are going to pull a lot of current, then this wire, this red wire, needs to go to a relay that uses a different power source. And that's probably the next video. But if this is how to hook it up to something that will all work. Now, in the video, I did say you could hook it up to a turntable, but the motor of a turntable pulls a lot of current. So it would just make all of this go seriously dim. Okay, so there it is. Have fun with this. And again, you get to control the time that these lights stay on by just moving this potentiometer up and down, and you're no longer tied to the length of the track, right? Um, in other places, you would just connect the BD20 directly to this without this middle thing, but you would be tied to the length of the track. So this is a way of giving you back that control. All right, enjoy. If you indulge me, there's a little bit to the rest of this video, and it's about my wife and how amazing she was and her photography. It's really amazing stuff. All right, talk to you folks a little bit. Bye-bye.